This is another video to help you to gain some more numeracy skills, which you will need for math, but also for science. Again, science uses math as a tool. When you do labs, you collect data, and you have to figure out other numbers from the data that you collect, and then you can interpret that data, and you can make more conclusions, and you can know what that data and what those numbers mean. Remember, Remember that they're trying to tell a story. So in this video, we're going to take a look at how to solve for variables. And when I say solve for variables, you might see that worded in different ways. So for example, someone might tell you to solve for x. Someone might tell you to isolate x. Someone might tell you to find x. And here's a clever joke where there's a triangle and the question states to find x. There's a way to do that with a formula, but this student here simply circled x and said, here it is. But I'm going to teach you how to actually find x and solve for x in a variety of different situations. You'll learn this in your math classes, but this will be very helpful in science and everyday life. Any situation that you come up with can be solved using variables and using different ways to solve for that variable. And just to clarify before we move on, a variable is a number that is different, that can change. So x will be different in different situations. X can be 4, x can be 5, x can be 6. Many times in science there'll be an unknown variable and you have to figure out what that is. So for example, you might see x plus 6 is equal to 10, and I might ask you to find, well, what is x? That's the unknown variable. And so right now, intuitively, you could probably guess, well, 4 plus 6 is equal to 10, so x must be equal to 4. And so that's, in your head, a way to solve for a variable, but I'll show you the math behind it. And if you think about this, this is used in everyday life. I mean, if you go to the store, you bought one item for $6, and another item you forgot the price, but you know, okay, the total was $10, well, you could figure out that the price of the other item that you forgot was probably $4. So again, it's not just used in science. This isolating and solving for variables is used everywhere. So it's one of the most important skills you'll be learning this year. Here are your learning goals as per usual. You'll have to know how to solve for an unknown variable using a variety of strategies and operations. And when I say operations, I mean things like add, subtract, divide, multiply. I also mean maybe square or square root. Those are a variety of different operations or things you can do to numbers. And then you'll be able to apply your ability to solve for unknown variables in the real world and in science applications. And there'll be a lot more science applications that we'll see as we move throughout the unit. So here we have a famous problem. You'll sometimes see these on Facebook, and someone will post it, and then people will comment and try to solve the problem. So you're given a series of pictures and numbers, and you have to basically solve for the final series of pictures over here. And in a way, when you're doing this, you're actually solving for variables. So for example, you know here that the apple is equal to 7, and well, if the apple is equal to 7, you can write that down over here. So 5 plus 7 is equal to the grape, to a bunch of grapes here. So that means the grapes, well, that's equal to 12. So we have our apple is equal to 7. We have our grape, well, that's equal to 12. And then we can continue going down to try to solve some more. So we know that 1 plus these bananas here, that's equal to the apple, and we know that the apple is 7. So if you know the apple is 7, and 1 plus bananas is equal to, well, 7, then that means this here must be 6. So now you have all this information, and you go and you can write down, well, the apple is 7, the grapes, that's 12, and the bananas we said were 6, but if you look carefully, here we had 1, 2, 3 bananas. So you know that 3 bananas is equal to 6. If 3 bananas is equal to 6, then 1 banana must be equal to 2. 1 banana is equal to 2. And you did that in your head. You said, well, 2 plus 2 plus 2, that's 6. Or maybe you did 6 divided by 3. And what you did is you did solving for variables here. So now that we know that, we have 7 plus 12, that's 19, plus 2, that's 21. So our final answer here is 21. So believe it or not, you actually did some solving for variables in your head yourself. And now we're actually going to see how to write that out in a mathematical way. But you do this in everyday life. So next time you see a Facebook post like this, you'll be able to answer, get the correct answer, and be one of the people that comments that actually gets it right. It doesn't matter if you get it wrong, you made a mistake, you just go back and learn from it, but you can think it through. And a lot of people usually, they can solve for variables, but they always forget this step here where they see the bananas and then they forget to divide. I hope I didn't miss anything. Maybe I wasn't paying attention. Sometimes they do that in the bunches of grapes as well. They remove a grape or something like that, and you're not sure if you have the right number still. So just pay attention to that. All right, so we have a variety of situations where you might need to find a variable. And so in this table here, we can see all the different situations in which you'll need to isolate for a variable. So when I say isolate for a variable, isolate, that basically means solve for a variable. Get a variable alone. You want something like this. You want x equals something. You want to figure out what that x is. But oftentimes you'll have something else with your x. So for example, here we might have x minus b is equal to a, where b is some number and a is another number. And you really want to get x just alone. You don't want x minus b. You want x alone. And so I'm going to teach you strategies in order to figure out how to get x alone and to figure out what x is. And basically to do that, you just do the opposite of what is happening to x. So through the next slides, I'm going to walk you through strategies. All the strategies are going to be from this table here. You can fill it out using your Word document that you've been provided with. So we'll do kind of the general strategy, and after we'll do a specific example for each one of these situations over here. But you basically do the opposite of what's being done to your x. So the gist of it is, if you have, let's say, x minus b, well, the opposite of x minus b is, well, to add a b. So you do x plus b, and then you can solve it from there. So I'll show you that in the next few slides. We're going to start off with this first situation here and make our way down to these situations over here. And then afterwards, once you're done watching this video and trying these out on your own, you can then try some of the practice problems from the numeracy booklet that you've been provided with. All right, so in this situation, we want to find x, solve for x, isolate x. Okay, those are all different terms that you might use. And so you can see that x is not alone. There's a b taken away from it. It's x minus b is equal to a, some number. So to get rid of b, you do the opposite of what b is doing here. B is minus b, so you do plus b. Now, let me write that out there. If you have x minus b, and you add a plus b, you need to do the same thing on the other side. Otherwise, you're changing the equality. This statement means that x minus b is equal to a. When you do x minus b in your calculator, it better come out to a. If you do x minus b plus b and don't do that on the other side, now it's no longer equal. So you're breaking rules here. So if you add b to one side, the other side gets jealous, you need to add b to the other side. So let's do that. So x minus b plus b is equal to a plus b. And now we just go and clean this up a bit. If you have minus b and plus b, that's like b minus b. It's like 2 minus 2. That's 0, right? So you can get rid of the b's now because you did minus b plus b, or 2 minus 2, or minus 2 plus 2. So now we have x plus 0 is equal to a plus b. Now you don't have to put the plus 0. You can actually, that x plus 0 is x, so you can just have x is equal to a plus b. And so now you've solved for x. Now we didn't get an exact number because we didn't know what a and b were. A and b can be different things depending on your situation. Let's do an actual sample problem together. So our result here is x is equal to a plus b. Some students might memorize that. They might say, when I have x minus b is equal to a to get x, I just do a plus b. You could memorize that, but it's always easier to just learn the strategy to get to that, because sometimes this might be written in a different way and it might not look exactly the same and you might not spot the pattern. So learn how to solve for the variable, doing the opposite of what's being done to x, and then that's a little bit easier than memorizing this. It's a lot more work to memorize, understand rather than memorize. So let's do our sample problem here. We have an x minus 6 is equal to 10. So in this case, it's the format that we saw here. Our 6 is our b. Sorry that my b's look like 6's here, but our 6 is our b, and our 10 is our a, and we want to find what x is. So let's do that strategy, and just to show you that your intuition can help here, you can probably do this in your head. Something minus 6 is 10. Okay, well, that's probably 16. So 16 minus 6 is 10, and that's exactly what x is. But let's just see how we get that using our steps here. So x minus 6, we want to get x alone, so do opposite of what's being done to x. So there's minus 6 here, so we'll add 6. So plus 6, and you have to do the same thing on the other side because the other side gets jealous. So 10 plus 6. Now you can clean it up. Minus 6 plus 6 is 0, so now we have x is equal to 10 plus 6, which is 16. And now you've solved for x. You figured out what the unknown variable was. A and B, we sometimes call them constants. Basically, they're not in the question that you're dealing with. They're going to be 6 and 10 all the time. The only thing that you're not sure of is our x over here. So you should be able to solve simple problems like this. Now we're going to go on and take a look at a different situation on the next slide. So in this case, it's very similar to the previous case, except this time we have x plus b is equal to a. So we have x plus b is equal to a. And again, you want to do the opposite of what's being done to x. So now what we're going to do is, since you're adding plus b, since you're adding b, you're going to remove b from both sides. So x plus b minus b is equal to a minus b. Now b minus b is 0. So you have x is equal to a minus b. And so that's our end result here. X is equal to a minus b. Again, some of you might try to memorize this. Don't memorize. Try to derive it, meaning come up with it yourself, so that you can actually learn the material instead of cramming things in your brain that you won't really understand. Let's try an example here. So x plus 6 is equal to 10. So similar to our previous example, except we have a plus in there as opposed to a minus. And again, you can do this in your head. Something plus 6 is equal to 10. That something is probably 4. But let's just carry it out mathematically, because I will ask you to show your work to solve for some variables. So we want to do the opposite of what's being done to x. So right now we have x plus 6. So to do the opposite, we take away 6 from both sides. So x plus 6 minus 6 is equal to 10 minus 6. And so 6 minus 6, that's 0, and 10 minus 6 is 4. So x is equal to 4. So you've solved for x. You found the unknown variable. Now we're going to try a different situation. Here we have bx is equal to a. Don't worry about the little red line underneath. That's because I copied it from Word and forgot to take away that red line. So bx is equal to a. What this means is b times x. So the numbers are right next to each other. There's no operation in the middle. Usually when there's no operation in the middle, meaning when I say operation, there's no plus or minus or anything like that, or line. That means multiplication. So b multiplied by x is our unknown here, is equal to a. So because x is being multiplied by b, you want to do the opposite. If x is being multiplied by b, well, the opposite of a multiplication is a division. Okay? So what you want to do is you want to do bx divided by b. So when I put the line there, that means division divided by b. So like that is equal to a divided by b. Now, when you have some number or variable over the division line, and some number or variable below the division line, they cancel out if it's the same number or same variable or same item or same unit. And the reason you can think of it that way is if I do 2 divided by 2, that's equal to 1. And so that's not really going to change anything or affect anything in my equation anymore. So what I'm going to do is I'm going to cancel that out. I'm going to put b over b is equal to 1. I'm going to write 1x is equal to a over b. I can't do that for a and b because I don't know if a and b are the same right now. They're 2 different numbers. Now in math, you don't have to write 1 in front of the unknown variable. You can simply write it as x. You do have to write other numbers like 0.5 or 2, but if it's 1, you don't have to put it. It's implied. It means we know it's there if you don't write it. You wouldn't put an x there if there was no x. So x is equal to a over b. That's our result here. X is equal to a over b. And just a reminder, at the top of the division, you call that your numerator. At the bottom, you call that your denominator. Numerator, denominator. Okay. So another thing I want to mention is you'll notice I wrote this a bit different here. I wrote this a/b. And it means the same thing as x is equal to a over b. Sometimes we just write it on the side to save some space, but it's the same division, a divided by b. Okay. So again, you could memorize that to solve for x, but a better approach would be to actually carry through the problem like I did here to get this same result. So now we're going to do a sample using actual numbers. So we have 4x is equal to 36. So 4 times some number we don't know is equal to 36. And if you're good at multiplication, you can probably figure that out in your head that it's going to be 9. But let's just carry this through. So x is being multiplied by 4. The opposite of multiplying by 4 is dividing by 4. So let's divide by 4. The other side gets jealous, so you divide by 4 as well. You have to do the same operation on the other side. 4 over 4 is 1, so you can cancel that out, and you get x is equal to 36 over 4, and then in your head, or using your calculator, but I would practice these multiplications in your head, x is equal to 9. So you've just solved for x. If you want to test to see that you're right, all you'd have to do is put the x back into the equation and see if you get 36. So for example, you put 4 times, now usually when you don't have the variable but you're putting an actual number in there, you put brackets like this, 4 times 9. This means 4x, because we're saying that x is equal to 9 here, so we're putting that in there. If you put that in your calculator, you'll see, yes, you actually get 36 again. So that actually satisfies, it actually makes the equation work. When I say satisfies the equation, it makes the equation work. And you could have done that for the previous examples as well. Put that x back in there and see if you get the answer that you're supposed to get based on the equation that you have there. Now we're going to try the situation where your x is squared. And when we say the x is squared, it means it's multiplied by itself. So here we have x squared is equal to a. Another way of thinking about that is x, I'm going to put this in brackets because it's a bit confusing if I don't, x times x is equal to a. So when we have x times x, we square it. If I had x times x times x, we put a 3 instead because it's multiplied by itself 3 times. So when a number is multiplied by itself, you put a little number on top called an exponent to show how many times it's multiplied by itself. So this is an exponent. Kind of like when we saw for the measurement videos. So in order to get rid of this squared here, you can use a function on your calculator called the square root. So to get x, what you do is you take the square root of both sides. So square root of x squared is equal to, you have to do square root on the other side, square root of a. And when you do the square root of something squared, well, that just gets rid of the squared part. So this is now going to be x is equal to square root of a. You have to keep the square root of a there because there was no exponent to 2 on top. The square root of a will be different depending on what the number is. So our result is x is equal to square root of a. So if you see something that is x squared is equal to something, then you just take the square root on your calculator. It'll look kind of like this symbol here, and figure out what that answer is in the end. So if you need help finding that square root function, you can ask your peers, you can ask your teacher, you can look it up online or through your instruction manual for the calculator. So we'll try this sample problem here together. X squared is equal to 64. So that means that something times itself is equal to 64. And you might already know that. You might know that 8 times 8 is equal to 64. And so that would be your answer here. But let's just try it out using the mathematical operation. So the opposite of squaring is square rooting. So we do the square root of x squared is equal to the square root of 64. So square root of x squared is x is equal to square root of 64. If you put that in your calculator or do it in your head, you get 8. So x is equal to 8. Again, you can verify to see if this is right by putting your x back into your operation. So we had x squared is equal to 64. Let's see if that actually works out. Let's see if we put an 8 in the place of x, will we get 64? So if you do 8, I'm going to put this in brackets to show that I'm putting the 8 where the x was. I'm going to put squared is equal to, you put that in your calculator and you'll see that you get 64, so that means you did solve for this accurately. So now we're kind of looking at the opposite situation where you have the square root of x is equal to a. So you're kind of doing the opposite here. The opposite of square rooting is squaring. So you have to square both sides. So if you have square root of x is equal to a, well, square the square root of x. So what I do is this, I put it in brackets, I put square root of x squared, square the a is equal to a squared. Now, technically you could leave it like this, but I like to clean it up a bit. The square root of x squared is just x because you're just taking away the square root, and is equal to a squared. You can't change a to anything yet because you don't know what a is. It depends on the number that you're looking at. So here we have our result. A is equal to, or x is equal to a squared. So we'll do a sample problem together here. We have square root of x. Square root of x is equal to 5. So to find x, we don't want the square root of x, we want x itself. We have to square everything. So square root of x squared is equal to 5 squared. And so the square root of x squared is equal to x, which is equal to 5 squared. And then afterwards what you can do is you can put this in your calculator or do it in your head. And if you put it in your calculator, you'll get 5 squared is equal to 25, or you can remember that 5 squared means 5 times 5. So if you had 5 squared, that just means 5 multiplied by itself twice. So 5 times 5. Any other exponent would change how many times you're multiplying it by itself. So if you have 5 cubed, that means it's 5 times 5 times 5. And there are situations where you can have that. You'll see that when we get to volume and density calculations. So just be aware that the exponent means how many times you're multiplying it by itself. If you need help to figure out how to do the squared function on your calculator, again, check with your peers, check with the internet, check with your instruction booklet, come and check with your teachers, because calculators will vary. So it's always good to try to make sure that you bring your own calculator to a test or quiz or exam, because you don't want to be figuring out the different functions on somebody else's calculator during a test or quiz. It just makes things a bit scarier for you. Alright, so now we're going to try to solve x when x is being divided by something. The opposite of a division is multiplying. So if we have x is divided by b, is equal to a. We want to get x alone. We want to get rid of the b. So the opposite of a division is a multiplication. So we're going to multiply both sides by b. So we're going to have x over b multiplied by b. So you don't have to put the multiplication sign. Some people like to put a dot. Some people like to write the b just right next to the x. So xb like this. Make sure you put it over the line though, is equal to a b. So you'll notice again you have b over b. So that's 1. So that cancels out. So x is equal to a b, and that's our end result here. X is equal to ab, which just means a times b. You might see a xb, so which means a times b. You might see a dot b. So I'm just going to write it down in the various forms you might see it. So a times b. You might see a dot b. You might see a b like this. These all basically just mean x is equal to a multiplied by b. So we'll try a sample problem together. We have x over 5, and again that just means divided by 5. So sometimes you might see x with the division sign 5 after it, and you'll do the same steps. So x divided by 5 is equal to 6. And in your head you might think something divided by 5 is equal to 6, and that's probably 30 if you're quick with divisions and multiplications. If you're not, just practice it. It's the only way you'll get better at this. So we need to multiply both sides by 5 because we're dividing by 5. So we're doing the opposite of what's being done to x right now. So x over 5 we'll multiply this by 5. So you can put the 5. Usually we put the number in front of the x. I know I didn't do that in the example there, but usually we multiply by 5 by putting the number in front of the x. So 5x over 5 is equal to 5 times 6. So I'm going to put 6 here. I'm going to put 5 here. You could have done 5x6. It's the same thing as what I'm doing here. Since I have 5 over 5 on this side over here, that equals to 1, so that cancels out, and I have 1x is equal to 6 times 5 from here, which is equal to 30. And again, you can go and verify to see that this satisfies the equation. So we have x over 5 is equal to 6. Let's see if that actually works out when you put your found x value into that equation. So 30 over 5, put that in your calculator. 30 divided by 5 is equal to 6. And it does work out. So that means that you were right when it comes to solving for x. And now we're getting to one of the last ones. It's similar to the other one that we saw, except you'll notice that x is a little bit different. It's on the bottom as opposed to being at the top of the division line. And so here you'll have to actually do a few different things to tweak it to get x on top. When you're solving for x, you want x to be in the numerator position. You don't want it to be in the denominator, because otherwise you're just getting 1 over x. You're not getting x itself. So our first step is to flip the equation somehow to get x on top. And so the best way to get x on top is to multiply both sides by x. So if I have b over x is equal to a, I'm going to multiply both sides by x, and you'll see what's going to happen here. So I'm going to have x, b, so when I multiply by x and make sure the b is on top of the line here, xb over x is equal to a x. If you multiply one side by x, you have to multiply the other side by x. Now you'll notice that, okay, I'm getting rid of the x here because it's x over x, which is 1, that cancels out. So I have b is equal to ax. Okay, great. I got x on top by doing the opposite, by multiplying by x because x was dividing there. And now I'm almost there, but I don't have x alone yet. I still need to get rid of that a, and some of you already probably guessed it. Well, since a is multiplying x, why wouldn't I just divide by a? So divide by a And then since you divide by a on that side, you have to divide by a on this side. Since you have a over a here, they cancel out. And so you have b over a is equal to x. And you can rewrite that as x is equal to b over a. It's the same thing. X is equal to b over a. A lot of students, for some reason, they get confused when they see it written this way, but it's the same procedure. You can just rewrite it. It's kind of like saying 2 plus 3 is equal to 5. You could write that as 5 is equal to 2 plus 3. It means the same thing. You just wrote it the other way around. So when you have a situation like this where x is at the bottom, you have to get x on top first by multiplying both sides by x, and then getting x alone means you divide both sides by a. So it's just a two-step problem instead of a one-step problem, but as long as you carry out both steps, you should be in a good position to get this general result over here. So we're going to try one sample problem together. We'll do the 49 over x is equal to 7, and we want to solve for x. So basically what that means is 49 divided by some number that we don't know is equal to 7. Okay. And again, if you're quick with math, you'll probably figure out that x is equal to 7 just by doing it in your head. But let's do it the mathematical way, because you can't. There's some numbers that you won't be able to do in your head. So we want to get x on top. So our first step is to multiply both sides by x. So 49x over x is equal to 7x. Again, notice that the x is on top here in the numerator. Now, since I have x over x on this side, that cancels out because it's 1. So I get 49 is equal to 7x. Just to clarify, I can't cancel out the x over here because there's no x at the bottom of that one. You can only cancel out where you have an x and an x in the numerator. So now I'm almost there. I don't have x, I have 7x. I have 7 times x. So I need to get rid of that 7 by dividing by 7, because it's multiplying here. So the opposite's the division. So you have 49 over 7 is equal to 7x over 7. 7 over 7 is 1, so that cancels out. So now you have 49 over 7 is equal to x. And if you put this in your calculator, 49 divided by 7, or just do it in your head, you get 7 is equal to x. And you can write it the other way around. You can write x is equal to 7. It doesn't change any signs or anything like that. You just write x is equal to 7. It's the same thing. You just wrote it from left to right instead of right to left. Don't change any signs. Don't get confused with that. So our value here is x is equal to 7. If you wanted to test that out, you can simply put it in your equation, 49 over x, and we know x is 7, so let's try that out, is equal to, put that in your calculator, 7. Since that x you found satisfies the equation, you know that you found the correct x. You have the right answer. Now sometimes you might get something that looks a little bit more complicated. You might have a variety of different operations, and you have to do a whole bunch of things to x in order to solve for it. And so usually in this situation what you want to do is you want to do the opposite of BEDMAS. Usually you want to do, for example, your exponents first in a calculation. You want to do whatever's in brackets first, then exponents. You want to do multiplication, division. You want to do addition, subtraction last. But in this case, you want to do the opposite of that. First add, subtract, then divide, multiply, then square root or square. So I'll show you what I mean by that. So we have ax squared plus b is equal to c. And our goal here is to solve for x. We don't want x squared, we don't want ax squared, we don't want x squared plus b, we want x. So first we're going to do add or subtract. So we have ax squared plus b is equal to c. We want to get rid of this b here. So right now the b is being added. So what's the opposite of adding? Well, subtracting. So ax squared plus b minus b is equal to c, and don't forget to do minus b on the other side. If you do an operation on one side, you have to do it on the other side as well, otherwise the other side gets jealous. But we can clean this up. B minus B is equal to 0, so we can get rid of that. So now we're left with ax squared is equal to c minus b. We're not quite done yet. We still need to get rid of the a. So once we've done the add and subtract part, we have to divide or multiply. It depends what a is doing here. So a right now is multiplying the x. So to do the opposite of that, you need to divide. So we have to divide by a on this side and divide by a on this side. Make sure you put the line under both letters here because you're dividing the entire thing by a. Now since you have a over a on the left side, you can cross that out because it's equal to 1. So you have x squared is equal to c minus b over a. Now our last step is to do the opposite of what a square is. So we have to square root. So we're going to do square root of x squared is equal to square root of this entire thing here. So put square root around the entire c minus b over a. And so our end result is going to be square root of x squared is x is equal to c minus b over a, and then the square root of that. Now you won't see many like this in grade 9 science. You will have to solve for stuff like this in math for sure, and you'll get better as you do more practice problems. And in grade 10 science, you'll see more of this stuff, more of these more of these complex variables that you have to solve for. But you'll see it's not too difficult once you actually get some practice with it. So let's try an actual practice problem out here. We have 2x squared plus 6 is equal to 38. So I'm going to start off by doing either the subtract or addition, depending on what the case is. So I have 2x squared plus 6 is equal to 38. You could probably do this in your head right now if you wanted to, and figure out what x has to be to give you 38. But I'm going to teach you how to do this mathematically. So let's get rid of the 6 first. Since that's the addition, we have to do a subtraction. So 2x squared plus 6 minus 6 on this side, and minus 6 on the other side as well is equal to 38 minus 6. You can get rid of the 6 minus 6 here. So you get 2x squared is equal to 32, because 38 minus 6 is 32. We're not done yet. We didn't find x yet. We just found 2x squared. So let's divide both sides by 2, because you want to do the opposite of what's being done to x. Right now, x is being multiplied by 2. So divide both sides by 2. And what you can do is you can cancel out the 2 here, because that's 2 over 2. Don't cancel out the 2 in the exponent. That's different than 2 divided by 2 here. This is why it's off right now. So you get x squared is equal to 32 over 2, which is 32 divided by 2, which is 16. We're almost done. Now what you have to do is solve for x itself. Not x squared, but for x itself. So to get rid of the square, you have to square root. So we're going to do square root of x squared is equal to square root of 16. Square root of x squared is x. Square root of 16, if you do that in your calculator, some number times some number needs to give 16, so that's 4. So x is equal to 4. Again, to see if you're right, you can simply put the 4 into the x of the equation, so 2 times 4 squared. Notice I'm just replacing the x that was here by 4, and then plus 6. So let's see if we can actually get 38. So that's going to be equal to 2 times 4 squared. So 4 squared is 16. So notice when I'm doing the actual calculation, I have to go with the BEDMAS order, the brackets. Let me write that down for you just in case you forgot what it is. BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. So when you're actually doing this problem here, make sure you go with brackets first, the exponents after, then division, multiplication, then addition, subtraction last. So we're going to deal with 4 squared. So I did my exponents first, done that. Now I'm going to do my multiplication. So 2 times 16 plus 6. I'm going to continue writing this out here because I'm just solving step by step. So now I'm doing my multiplication. 2 times 16 is 32 plus 6. Now I'm going to do my addition last. 38. And so we've solved for x properly, because when we put x back into the equation, we get 38 again, just as we're supposed to. So now that we've gone through how to solve for x or for an unknown variable, sometimes your unknown variable might have a different letter. It might have D, it might have Z, it might have Y. The point is that you're solving for some unknown thing that you don't know. Most oftentimes we use x, but we can use other letters, like I said. So now that we've done that, you should be able to do a variety of problems where solving is required. Start off with the numeracy packet booklet. Try these problems too. Go on Facebook, not to waste time, to try math problems, hunt math problems down there, and try to solve these little riddles here. Pay attention to the horseshoes. Pay attention to what the variables are. In this case, the variables are horses, horseshoes, and these boots over here. So try to solve for that. See if you're able to do it using a variable. To challenge yourself, try this riddle over here. A bat and a ball cost $1.10 in total. The bat cost $1 more than the ball. How much does the ball cost? Think about this carefully. Try the problem out. Come up with an answer. Compare with a peer. Try with a partner. And see if you got the right answer or the wrong answer. There is an answer that's wrong that a lot of people come up with right away. So if you get it wrong, don't worry. It's actually a very famous riddle because people don't think about the problem carefully. If you solve this using variables, you'll actually see that the answer is quite doable. So for example, a bat and a ball. I'm going to call the bat X. I'm going to call the ball, let's say, Y. Okay, I'm just going to put variables here right now. X plus Y, we know the bat and the ball together, they're equal to $1.10. I'm going to leave the unit out right now just so I don't get too confusing. There's too many unknown things here. 1.10. Now, it says that the bat cost $1 more than the ball. So I'm going to write an equation for the bat here. I'm going to put the bat, X, is equal to the ball's price plus $1. So Y plus 1.00. And I want to figure out how much the ball costs. So here's a neat trick I'm going to teach you. Notice how we have X is equal to Y plus 1. It's hard to solve for the price of the ball, Y, when you have another variable if you don't even know the price of the bat. So what I'm going to do is I'm going to take this Y plus 1 and replace my X by it in that first equation, because X is equal to that. I can do that. I can put Y plus 1.00, because that was what my X was, is equal to 1.10. Oh, I forgot to add my Y that was there. So I replaced my X, but I can't get rid of my Y yet because my Y was still there. So all I'm doing is replacing my X by some other term that it's equal to. Plus Y is equal to 1.00 or 1.10. Now I'm going to say, don't worry if you don't get this. It's just a challenge, a little riddle to think about, and I'm just going to show you how you can use your math skills to solve it. So now I'm going to clean up this equation. You're learning in math that you can simplify terms, right? If you have Y and Y, the two of the same variables, you can add them together. So 2Y plus 1.00 is equal to 1.10. And now at this point, you should actually be able to do this part here. You should actually be able to solve for Y now, because I think we said the price of the ball, we just made it the variable Y. That's the letter we gave to it. You could have put B or A, whatever, it doesn't matter. So now you can solve for y. Remember, you have to get rid of your addition first, then afterwards you can do your division. So let's take away 1 from both sides. So 2y plus 1.00 minus 1.00. Now that's just decimals. We'll see why those decimal places are there later on. You could have just written 1, it doesn't matter. Is equal to 1.10 minus 1.00. Get rid of the 1's here because that's equal to 0. So now we have 2y is equal to 1.1 minus 1, which is 0.10. We almost have y. Y is being multiplied here. So now we have to divide. Divided by 2 on this side, divided by 2 on this side. And so you cross this out, because it's 1. And now we have y is equal to, if you put this in your calculator, you get 0.05. So what this means is, this 0.05, this is 5 cents. Okay, we have 1.00, that's $1. Okay, you have 1.10, that's $1.10. So in the case of money, when you have the whole number here, that's the dollar, and when you have the decimal part here, that's the cents. So anything in a decimal is a cent. So here we have 5 cents. Okay. If you just had 0.10, that's 10 cents. If you had 0.50, that's 50 cents. So to actually get 5 cents or 9 cents, you have to have 0.05. So we know now that the y, which is the ball, is 5 cents. Does this make sense? Oh, bad joke. Well, let's see. We said that together, the bat and the ball have to be $1.10, and that the bat is $1 more than the ball. So that means that the ball must be $1.05. Oh, sorry, the bat must be $1.05, and the ball must be 5 cents, which is equal to $1.10. Now again, this was just a challenging riddle. You don't have to get this right. You're not going to see something this complicated yet in grade 9 science. But I mean, it's always fun to try to come up with variable systems to solve this. If you want more challenges, just you can research many more online. So now that we've completed this PowerPoint, you should go and try the isolating variables practice problems from your numeracy packet, and try some more practice problems from your math homework. Go online, practice together. The more practice you do, the better you're going to be at solving for equations when we get to this in science.